So now let us look at this question. It looks sometimes a little daunting, no? It has so many springs, 3 springs here, 3 springs there, a huge number of pulleys. Extremely easy question. Okay, let us start with one simple idea. Let us say that this fellow moves up X. Now, how do all the pulleys behave? That is a real question. Well, if this moves up X, what's the tension here? The tension must be equal to Kx. But if this tension is T, this tension is T, 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 T. Right? So, if both sides tension is T, what is the tension there? 2T. So, the tension here must be 2T. And then tension there Tt, so this must be 2T. And luckily all pulleys are all massless, smooth. We don't need to worry about any of the other conditions, right? So, it's simple. Now, if you have T and T, you have 2T here. And then you can see that these two are T's, so that means this must be tension 2T, this must be tension 2T. But if this tension has to be 2T, this spring must have extended such that this must be 2T. 2T will be 2Kx. But that must be equal to K times the extension of this fellow, I will call it Y. So therefore, you can see that once I cancel this out, Y must be 2x. I won't write Y, I will just say that this point moves down by Y, which is 2x. So I'll just write 2x. So this pulley comes down by 2x. You can see that, right? If this point is, this spring has to extend by, so that point is fixed. So this is going down by how much? By 2x. The pulley is coming down by 2x. Now let us come to this fellow. Here what is the tension? 2T. T is Kx. So 2T, which is 2Kx, must be 2K times Y dash. So if I cancel this out, you can see that Y dash must be equal to X. So this fellow here is coming down by X. Why is this coming down by 2x and that by x? Because this is K spring and that is 2K spring. So to give you a tension of 2T, you just need an extension of x here, whereas to give you a tension of 2T, you need an extension of 2x here. Okay? And what about this case? Well, this case is exactly like this case. So that means you can see that 2T, so 2Kx must be equal to K into what? K into 2x. So I know this pulley goes down by 2x, x, 2x. And then let's come here. Now it's tension. Tension is always pulling. So that means this place is also getting pulled. So this will also extend. Okay. So if this fellow has to extend, how much will it extend by? 2T, and that is 2K. So this is 2T means 2Kx divided by 2Kx. So therefore this pulley is going up by x. And what about that fellow? That is 2T and this is K. So therefore it will go up by 2Kx by K. So what do you get? 2T is 2Kx by K. So you will get 2x. So this fellow is going up 2x. So I hope so far it's clear to everybody. Because once you have got a hang of this, the rest of it is very simple. Because if this fellow goes down by 2x, right? This fellow goes down by 2x. I am going to say there is a slack of how much? When the pulley goes down by 2x, there is a slack of 2x on this side and 2x on that side. And this fellow has gone up, which means the rope would have an additional slack here of x. And now this pulley has not even gone up. I have not even lifted this pulley. So when I lift this pulley up by x, so there is going to be a slack of x here and x there. Now let us move that pulley down. So you are going to get x here and x there. And then this fellow goes up 2x. So you are going to get on both sides, because just hold this and lift it up by 2x. You see that there is a slack of 2x on this side and 2x on that side. Have I moved this yet? No, right? I have moved this pulley. I have moved this spring. I have moved this spring and therefore moved this pulley also. I have moved that pulley. So this is done, this is done, this is done, that is done, this is also done. What is not done? This is not done. So this fellow moves by 2x. So which means there is a slack of 2x, 2x. Is it okay? Clear? Now once you have got this, all these slacks have to make this fellow go down. How much is that? X plus 2x plus 2x plus x plus x plus x plus x plus 2x plus 2x plus 2x plus 2x, right? You can keep doing that. So how many 2x's do I have? I have 1, 2, 3, 4, 5, 6. Right? I have 6 2x's. So that means 6 into 2x plus How many x's do I have? Should I have an odd number or an even number? Let's quickly check that. Okay, because every time the pulley moves, it's double, except for this guy. So I had an even number of 2 x's, but how many odd? I should get an odd number because this will be 1, right? Let us check. So I have a x here, 2x, 2 times, 3 times, 4 times, and nothing else, right? Correct? That was all 2x, 2x, 2x. So this is once, twice, thrice, 4 times. And then I have this fellow. So that is 5 times. So I have 5 times x. So this is 12 plus 5. 12 plus 5 is how much? 17x. So this block must have moved down by 17x. Okay, so this must be 17 times x. So if the spring goes up by x, that fellow comes down by 17x, which is a lot, right? Obviously, because there are so many springs connected. Now, this also means that this fellow's velocity, if I look at this fellow's velocity and say that this guy's point is moving up with some velocity, this would have been 17 times that, but I don't need it because you see none of the others have kinetic energy. So I'll just call that fellow V. If I had a block here, I could have added that information saying if this guy has moved up by x, this fellow will have a velocity of v, that fellow will have a velocity of 17v, which I don't need in this particular case. Now, unfortunately, the question asks us for 2 things, maximum height and also maximum speed, right? So, let us calculate what will happen at maximum speed and what will happen at maximum height. At maximum height, what will happen? Maximum height, this fellow falls by, maximum depth basically. When it comes down, at that point, the speed will become 0. So let me put it this way. Let us say somewhere here you get V max and here you get V equals 0. Because at maximum height V equals 0, this is when V equals 0 and this is V max. But what happens at V max? A equals 0. Acceleration has to be 0. Now why is there an acceleration? Because there is a tension. And then there is an mg. So net force must be 0, then only then you can get acceleration being 0. So let us start by writing down that information here. So when V is maximum means net force must be 0, net force is mg minus t, right? mg minus t, but you know t is kx. So mg minus kx must be equal to 0. Because whatever is the tension here is the tension throughout this row. Right? So mg equals kx. So what is x then? So I'll call this x1 because then we can call this x1 and we will call this whole thing x2. Actually I shouldn't call it x1, I should call it 17x1. Okay, this is x. So this is 17x1, this will be 17x2. That's good to write down because x1 and x2 is this x. Right? So kx is actually the force, tension force. So kx is still kx1. So if I now look at this, what is x1? mg by k. What is mg by k? This is, by the way, this 17x1 is the amount it has gone down by, but the tension depends on this spring. Okay, it doesn't really depend on m because going down here doesn't change your tension. Only this extension matters. Overall, this guy would have gone by 17x. Okay, now I have got m to be 20. So 20 into 10 is 200 and we know k is 50. So divided by 50. So you can see that will cancel out giving us 4 meters. So x1 is 4 meters. What is the depth it falls down by at that time? It will be 17 times x1, which I don't right now need because I need to know the speed. I will also tell you later a nice shortcut because this will allow us to calculate both. In fact, I'll tell you the answer now, but that is not something that you right now know. If I know the equilibrium position must be exactly midway between 0 here and 0 there. So I know that at equilibrium position, it has come down by 17 times x1. What is 17 times 4? 17 into 4, right? So this is 17 times 4. So how much is that? 17 into 2, 34 into 2, 68. So it has come down by 68 meters here. I am going to claim that from here to there it will be another 68 meters. because equilibrium is halfway. So that means the total distance it would have come down by is 68 plus 68, which is how much? That is going to be 136, right? Is that right? 120 plus 16 is 136. So I know the answer to the first question is 136. I didn't use energy yet, but I cheated because I used something else that you probably don't know yet. That equilibrium position will be midway. Okay, when we learn about simple harmonic motion, you will be able to see that. But let us calculate this now. I am going to do 3 pieces together in one table because I have both the questions, right? So I will do initial, I'll call this initial, this is the final, and we'll call that middle. So we'll say initial, middle, final. So this is the mid. Middle does not mean necessarily midpoint. Okay, it may turn out to be so in this case, but in general we don't need that. So now, if I now look at all my springs, it's a little bit of a mess, right? So many springs to deal with. And then I have potential energy, kinetic energy. What I will do is I will add up all the energies of the springs so that we can do it in one shot. But just to be simple, for what we will do is all the springs with X. So this is spring energies with X. And then we will do spring energies with 2X. Because you see, every spring is either extending by X or 2X. So why don't we just bundle them together? So we can do that, right? So that will allow us to do the calculations a little easier. You can actually bundle even the whole thing together, but this will allow us to do the calculations easier. Potential energy and then kinetic energy. My initial position, I am going to say at that level, initially all the springs were at 0 energy. It was all unstretched, that is given. Now potential energy, I can select my 0 level there, or I can select my 0 level here. Where should we select our 0 level? Let us select the 0 level initially. So if I select my initial 0 level, then potential energy is 0. So this is what I am going to call 0 level. Okay. Then I have gone down 17x1 and I have gone down 17x2 from the 0 level. Kinetic energy in the beginning was also 0. So this was nice and simple, 0. Let us go to the middle case. So if I get to the middle or at any point, let us see how many springs have X. So that means half K X square, right? So it is going to be half something here X square. But here you know that X is 4 because X basically is 4. We calculated that. So this is going to be half K 4 square. What K should I put? Well, each of the fellows that was extending by X. Now what do you have here? This fellow would have given you half K X square. This is also X, half 2K. So K plus 2K is totally 3K. So I have counted this, I have counted that, 3K. This is 2X, we won't count that, but that is X, right? So we'll count that fellow. So how much is that? Right? 1K, 2K plus 2K. So how much is that? 5K so far. We have counted all of these. And have we counted this one? No, that is 2K, we won't count that. This fellow is 2X, we won't count that. This is 2X, 2X, we won't count that. We are counting this spring, we are counting this spring, and we are counting this spring. So how much do I get? 2K, K, 2K, so 5K. So I should put 5K. Do I know what K is? I'll write 5K, then we will calculate and put it in. And when I come to this fellow here, it is 2X whole square. So 2 times 4 whole square. So this is 8 whole square, half into the spring here. Now this is, I am counting all the springs that are extended by 2X. All the springs that are extended by 2X are these fellows. I will circle them. So there is a K which extended by 2X. This was not that one. This fellow extended by X. We have already counted these guys. This fellow extended by 2X. So I am going to circle this one. And then this fellow extended by 2X. So I am going to circle that one. Okay. So K, K, K. So that means this is 3K. So I'll just put 3K here. And finally also I'm going to get half 3K into extension square, but I don't know what the extension is, right? We are going to say the extension, let it be X. So here it is going to be 2X. So each one is going to go 2X. So it will be 4X square. And here it is half 5K into X square. We don't know X. I am predicting that X into 17 will turn out to be 1 36. Well, x was 4, so this time it will be double, so it's going to be 8. We are going to see that it's going to be 8. X will turn out to be 8, right? So what about the potential energy? Well, this guy here has come down by 17 times x1. What is the mass? Mass is given, it's 20 kg, m into g into 17x, 17 into 4, which is 68 down. So it is minus 68. And finally, I don't know how much it has come down, but it has come down by 17x2 or 17x in this case. So 17x down, that's also minus, and then mass into g, which is 200. Okay, because it's come down by 17x. And kinetic energy at this point is the maximum kinetic energy. We are going to say that that has a velocity of v. So half into mass into v square. Whereas kinetic energy at the end is going to be 0 because it stops, because maximum speed, right, acceleration is 0, but maximum height that it falls by velocity will be 0. So kinetic energy is 0. Okay, so this total was nice, but that must be equal to this total, must be equal to that total, you know that. What about this total? Let us try to add up. Now if I see this, I have a 5k, but k is known. K is how much? 50. Okay, so this is 5k into 4 square, 3k into 2 square into 4 square. So 2 square is how much? 4. So if I do 4 times 3, I'll get 12 plus 5, so I'll get 17. So this is 17 by 2 k square. What is k square? Well, I've got not k square, sorry, 17 by 2 into 4 square into k. K is given, k is 50. 17 by 2 into 50 into 16, because 4 square will give me 16. Minus, I have here 200 into 68, or 200 into 17 into 4, right? Because I'll just split up the 68 as 4 times 17. So let me write this as 800 into 17, just for calculation purpose. And then you get here 10 v square. So this is one part. That must be equal to this whole thing. So let us write this also, and then we will try to simplify so that we can get both answers together. So let us see this. So you see that here again you have 12, and then you have 5, which makes it 17 by 2 k. What is the k value here? K value turns out to be 50. And then you have x square. Here I don't know x square, there I knew x square. Here I know v is 0, there I know x, but I don't know v because I knew x from the force condition, right? So where is the force condition? Here. So we use the force condition to find out what is x. Whereas here we don't know x, but we do know speed must be 0. So there are two different models of solving this, right? So this fellow is 17 by 2 into 50 into x square minus 200 into 17x. Now let us take the first one and then let's take the second one. Again, start whichever way. Let me say that this fellow is 0. Well, if this is 0, you can cancel out the x and you can cancel out the 17. So if I cancel out 17x, you can see that I have 25 sitting here. So 25x must be equal to 200, right? 25x must be 200. So how much is that? So x must be equal to 8. So you got x is equal to 8 in this case. X is not the distance. X is just telling you that the final value x is double of the initial value, I mean the middle value x, equilibrium was halfway. So if this is x, 8, so 8 times 17, correct? 8 times 17 must basically be 136, because I told you 4 times is 68 and then double of that. So that means it must be 136. So we know that if x is 8, the answer for maximum height we know must be 17 times 8, which is 136 meters. So that's the first part. Okay, so that is basically using the final state. Now let us use the middle state, which is basically this part. So if I take everything to one side, I can calculate. So let me do that here. So if I brought this fellow here, I get 10v square. 10v square. Let us take everything else to the other side. So we get 17 times, well, let's cancel this guy. So this is 8. 8 into 50, how much is that? This is 400, that is 800. So that means if I take it to that side, I'll get 800 minus 400. so which is 400. And so if I cancel this out, I get 40 times 17. So V must be 2 times root of 170, right? Because it's 170. So this is 2 times root of 170 meters per second. It's a very messy answer, but we can calculate that. So speed, maximum speed is root of, well, this was actually root of 680, right? So it is root of 680, which is equal to 2 times root of 170 meters per second. Now we can calculate that later. So right now what I want you to know, maximum height that it falls down by is 136 meters, by the way very long, so this must not be, this is not something that you can do in your house, right? 136 meters is huge. And maximum speed of m is root of 680, which is 2 root of 170 meters per second. Very simple. The main point is, can you draw this table out, and when this fellow moves by x, can you figure out what is the displacement of this point, this point, this point, this point, this point, etc. Obviously this is not a question that you're going to be able to do in 1 or 2 minutes, but it's not too long. Okay, the basic idea is that as the spring expands, that will expand, this will expand, that will expand, but not all with x. So if this is x, that is 2x, this is x, that is 2x, etc., etc., that is also x. This is 2x and that is 2x, right? So you will need to figure out how much each one moves, and if this fellow moves by some amount, that fellow is going to move by 17 times. That we use freeze and slack to find out. So once you combine all of these ideas, then the problem becomes reasonably straightforward.